Oh, welcome and thank you for joining. Let's take a look at the combinations of transformations applied to the graph of a basic trigonometric function. And this time I've selected the sine curve. And the equation we are working with is y equals 50 sine of 4x plus 180 degrees plus 30. First, we'll observe how the transformations are applied to a basic sine curve. Now remember that the basic sine equation will be in the form y equals sine of x. And all the transformations we can apply to the graph of y equals sine x are dictated by the coefficients a. A is the number that multiplies the sine function. K is the number that multiplies the independent variable x. P is the number that we subtract from x, and C is the number that we add to this entire function. Now, in what ways does each coefficient affect the graph of a function? Well, first, the coefficient A will indicate the amplitude, and the amplitude of a function is the distance of the max or the minimum from the axis of symmetry. So that would indicate the amplitude. Now, the coefficient A can be either positive or negative, which will take the sine curve reflected to the axis of symmetry or reflected to the horizontal axis. That can be the x-axis or it can be the axis of symmetry. The coefficient K will indicate the number of cycles within one basic period. Remember that the basic period for sine and cosine is 360 and for the tan function is 180 degrees. The coefficient P indicates the phase shift, and in the meantime, the starting point of the cycle. And lastly, the coefficient C, which is one of the most important coefficients in terms of the order in which we analyze it when graphing a function, is the one that will tell us the vertical translation of the graph, and it will define the location of the axis of symmetry. So axis of symmetry is always in the form y equals c, no matter what transformations we apply and no matter what the values of the other coefficients are, y equals c will serve as the axis of symmetry. Now you can see this on the graph of the function. So this would be the amplitude again, is the distance of the maximum from axis of symmetry or minimum from the axis of symmetry. When the amplitude or the value of a is negative, so we'll see the graph of this function go to the other side of the axis of symmetry. Now, the phase shift will be the start of the cycle in here, and the end of the cycle will be one period length later. Period length is the horizontal length of one cycle, and it varies depending on the number of cycles that we fit within 360 degrees. So let's get started with our example. So we have in here y equals 50 sine 4x plus 180 degrees plus 30, which we must bring in the form a sine k x minus b plus c. So in other words, we have to start off by factoring out the coefficient k. This is very important, one of the easiest mistakes to make. Please don't make it, it's very easy to avoid as well. So we're going to rewrite this equation with k in factored form. 50 sine 4x plus, remember 180 now is divided by 4 because 4 is a factor, 45 degrees, and then plus 30. So whenever I graph a trigonometric function, I try to look at the vertical coefficients first and then the horizontal coefficients, because setting a good scale is important, and without understanding what transformations and what coefficients we have in the equation, we cannot set a good scale. So the coefficient A in here is equal to 50, which means that the amplitude of the function will be equal to 50, or the distance of the function from the axis of symmetry would be equal to 50. And the axis of symmetry is at y equals 30. Now I'm going to use the amplitude of the function and the axis of symmetry in order to determine the maximum and the minimum value of the function. Now remember that the maximum will be starting from the axis of symmetry, which is 30. Add the amplitude, which will be the absolute value of 50. In our case, it's a positive number. So the maximum value would be 80, whereas the minimum would be 30 minus the amplitude, 30 minus 50, which makes this equal to negative 20. So knowing what the max, the min, and the axis of symmetry is will help me understand where to draw the horizontal axis. So as you can see, the values of y will vary from 80 to negative 20, which means we're going to need plenty of room in the positive y values, not as much in the negative y values, which will make me think that if I were to draw the horizontal axis in this much space that I have, I can draw it at the bottom down here. Now, next we're going to look at the horizontal coefficients. So the horizontal coefficients we have in here are coefficient k, which is equal to 4. And the coefficient k will help us determine the period length of the function. The period length will be basic period 360 degrees divided by 4, which will make this graph equal with a period length of 120. Now, next we need to look into the horizontal translation or the phase shift, which in our case is equal to negative 45 degrees. So that means that our graph will start at negative 45 degrees and will end 120 degrees later, because it will take 120 degrees for the graph to complete one full cycle. So with this then, I will have a better understanding of where to draw the y-axis. You see that the x values start in the negatives and the and will end in the positives, and that means that I'm going to need some room in the negative x values, which means that I cannot draw the y-axis right here. I cannot draw the y-axis right here either, because then I will give too much room to negatives, not as much to the positives. But I would reasonably draw the graph right here, where I have just enough room to draw my negative horizontal shift in here, and then enough room to end the cycle. So let's get to work. Now that I have set up my axis, I have to scale them. And I prefer that we use a blank area to draw the graph, because it allows for more freedom rather than counting the squares and trying to number them. So first we're going to label the axis. Very important, again, very often overlooked. So this is the y and this is the x axis. Now I know that my cycle will start here at negative 45 degrees. So I will give enough room to negative 45 degrees. In our case is somewhere in here. Now, because we know that the cycle will be only 120 degrees, it means that the graph will start at 45 negatives and it will end 120 degrees later, which means that from negative 45 degrees, we add 120, and negative 45 plus 120 will be 100 minus 25, so that's about 75 degrees. So if this is a 45 degree angle right here, I'm going to set a 45 in here as well. That will make, will take us at 90 degrees. And since we have 45 degrees, a multiple of 15, so I will divide this into increments of 15 degrees, and I will indicate it at least in one of them, that's 15. And now I'm going to go 45 degrees later in here, same size, and I'll divide this into increments of 15. Now remember that if this is another 45, we're going to hit a 90 degree angle right here. So far we have 45, 45, that would be equal to 90. And we will need 120 in total. So which means we're going to need two more increments of 15. And this is where the cycle will end in our case. This is where the 75 degree angle will be. And I will highlight the start and the end of my cycle so that I will remember it as I'm graphing. And now it's time for me to draw to scale the y-axis. But now I know that my cycle will be this wide horizontally. Now, as you can see in here, we have a maximum of 80 and minimum of negative 20. So I start off by scaling the smaller size. And obviously need to keep in mind that it's going to be taking up 4 times as much room as 20 units in the negatives. So let me just make this a little bit smaller. And we'll start off with the negative y-axis. We can also start off with a positive y-axis. Say, for example, we can make the graph here be, let's say, 80 units. And then cut it halfway, that's 40. Cut this halfway, that's 20. And this one here would be a 60. Now, I know how big a 20 unit on the vertical axis is. So I'm going to make this as big as the 20 units and mark it as negative 20. So now I can see that the graph will have the height of from negative 20 to 80, so about 100 units. And you can tell that this is the axis of symmetry. We can conveniently draw the axis of symmetry very easily here. So we're going to go at exactly 30. That's our AOS. And we know that the graph is going to start at 45 degrees. So we'll mark this point. It's a sine curve, which means that it will start on the axis of symmetry and it will end 120 degrees later, as big as the period length. And we know that the sine curve will have 3 points along the axis of symmetry. So all we have to do now is count our little units and then check and see where the middle of the graph will be. So as you can see, we have 1, 2, 3, 4, 5, 6, 7, 8 units. So 1, 2, 3, 4 from either the right or the left, and then we hit the middle. Now, halfway, the first half of the cycle, the graph will hit the maximum, and we know the maximum will be 80. So here we go. I'm just going to very quickly indicate this. With the broken line, and halfway the second half of the cycle, the graph will hit the lowest point, the minimum, and that would be all the way down here, and it will be at 45. Now let's mark the points. Let's mark this point, and let's connect the 5 points. This is what we call the 5-point graph. And obviously, not every point will be super duper accurate, but we do want the 5 points to be clearly indicated on the graph, and we should be able to read the start and the end of the cycle and where the minimum and the maximum is, and use the little broken lines to indicate that if scaling has become a little bit messy. And another very important detail that we want to add is the equation of the axis of symmetry. In our case, that would be at y equals 30, and label all the points where the important features of the graph are shown. Let's say, for example, the axis of symmetry, the minimum and the maximum. So we're going to make this even more complete. This is the maximum. Here is the minimum. Now, one last step before we finish up the entire graph. Check and see if this graph is compatible with the equation, which means that you got to check if the amplitude that you have created in here is exactly 50 units as it is indicated on the equation. So, and it seems that it is. And the only reason I want to do this is because sometimes it's very easy to miss a number or to skip a scale, and we want to make sure that we draw the most beautiful and accurate graph. So I hope you found these instructions useful. And I encourage you to continue with the next example. Remember that the cosine function will work in very similar way to the sine function. Thank you for learning with me. Bye for now.